Before we get into the topic today, I was at church service this yesterday, and there was a baby. She had to have been 7 years old, 8 years old. She was a baby, and she recited the entire chapter of Psalms 91. The entire chapter, word for word. Word for word. If you look at Psalms 91, this child said the whole chapter, Psalms 91. So when I saw that, man, it inspired me, and it really showed me that, man, our children can do anything, do anything that we can teach them. Mom taught the child Psalm 91. Dad taught the child Psalm 91. Dad said you can do it. So what we're doing here on this show is using some of these same principles, but with math. Our children can do anything we teach them. We just have to possess the competency, the passion, commitment, and connection. And our children will do it. So you go through, you check those videos, go to the Facebook, Students Dominate Math, and you check out those techniques which we're trying to get our students to do. And if we teach them early enough, they'll be able to handle. Now, let's move on to today's topic. It is a topic I'm surprised that I have never talked about this topic, but it's one of the areas which causes our children the most challenges. They experience the most challenges on this topic today called factoring. And while we talk about factoring, what I'd like to do is just, and I hope we can get a couple calls, because I've got questions with in factoring. There's a word factor. So I'm just going to say a number, and the thing I'd want to hear from you is to give me different factors, to give me different, I'm going to say like the number 8, for example. And when I say the number 8, the thing I'd want students to call in and say, what two numbers multiplied together can give me 8? All right, so give me all the combination, the pairs of numbers multiplied together to give you 8. It's one of the key ideas in factoring. The number 8, I'd love to get someone to call in and tell me two numbers multiplied to give me 8. You might say 4 and 2. 4 and 2 can be multiplied together to give me 8. Or 8 and 1. 8 times 1 multiplied together will give you 8. Or and this, some people don't think about this, a negative 8 and a negative 1. The product of those two numbers will give you a positive 8. Or a negative 4 times a negative 2. Those two numbers multiplied together can give you 8. You being able to do this is important in factoring. Let's try another number. 16. Can I get someone to call in? I want a student to call in and tell me what two numbers multiplied together can give me 16. All right, and I need some calls right now, but I'm not getting them. So if you want two numbers multiplied together to give you 16, you can say 8 and 2. Positive 8 and positive 2 will give you 16. Or positive 4 and positive 4 will give you 16. Or you got to be able to do this to factor, to go through this process we call factoring. Or 16 times 1 will give you 16. Or negative 16, negative 1. That product will give you 16. Negative 8 times negative 2. Two negatives multiplied together will give you a positive. Or negative 4 and negative 4. All right, so let's go through some problems and utilize this idea of coming up with factors of 16. Different numbers multiplied together that will give you the 16. In fact, I think I want to go through one more. Let's say we have a negative 25. I want two numbers multiplied together that will give you a negative 25. negative 25. Well, now when you want a negative product of two numbers that are negative, one of the numbers has to be negative, the other one has to be positive. I'd love to get some phone calls. I'd love for someone to call in and tell me this number times this number will give me a negative 25. But because you're not calling in, I'm going to say it myself. A negative 25, positive 1. You see how I change the signs? Or a negative 1 and a positive 25. Okay? Or a positive 5 and a negative 1. A positive 5 and a negative 5. Excuse me. A positive 5 and a negative 5, because we want a negative 25. All right. So let's just jump into a couple of factoring problems. This is one of the major topics in math that students sometimes have challenges with. Let's jump right into it. All right. So let's say we would like to factor. Let's say we'd like to factor x squared minus 12x plus 35. All right, so we want to factor that. What you have to do is first notice that you can't pull anything out. We can't pull anything out of this trinomial. So what we're going to do is set up two binomials. And this number and this number, you have to ask yourself what two numbers multiplied together will give you x squared. What two numbers multiplied together will give you x squared? Well, x times x will give you x squared. And now you have to ask yourself what two numbers multiplied together will give you a positive 35. What two numbers multiplied together will give you a positive 35. But when you check it, you will get a negative 12. The thing I'd like you to be able to see is you'd ask yourself, you'd go through the same process of what we did earlier in the show. What two numbers multiplied together will give you a positive 35? Well, you say 35 and 1, positive 35, positive 1, or you say a negative 35, negative 1. But then you'd come to the conclusion that you want to get a negative 12. So you try a negative 7 and a negative 5. And the thing that I ask my students to do is check their work. You multiply the outers, you get negative 5x. You multiply the inners, you get negative 7x. Notice how it gives you a negative 12x, which is this middle term, which confirms that this is correct. This is not the answer down here. You're just checking to make sure that your factored work is correct. All right, so that's called factoring. Now, a lot of factoring is the beginning process of a lot of larger ideas that you need to be able to factor to solve some more advanced problems. But factoring is the backbone idea, being able to factor. All right, so let's look at another problem. Let's say you have x squared. Let's say you have x squared minus 13x minus 48. All right, so we're factoring that. Notice again, you can't pull any term out of this trinomial. So you set up two binomials, like so. And then these two terms come from what two numbers multiplied together will give you x squared. What two numbers multiplied together will give you x squared? Well, again, x times x will give you x squared. The two numbers that go here and here are what you'd ask yourself, what two numbers multiplied together will give you a negative 48? What two numbers multiplied together will give you a negative 48? Well, the thing I'd like you to be able to see is you go through the process that we showed you earlier. So you'd identify two numbers multiplied together that will give you a negative 48. Well, let's just try a plus 8 and a minus 6. You need a positive and a negative. Like I said earlier in the show, to get a negative 48, you got to have a positive number and a negative number. All right? And then 6 times 8 is 48. Now, it turns out, I ask my students to always check their work. You multiply the outers, you get a negative 6x. You multiply the inner two terms, you get a plus 8x. And you get a 2x, which is not, you're trying to get a negative 13. You're trying to get a negative 13. So, because 2x is not the same thing as negative 13, this is not correct. This is not correct. But if you're first starting out with factoring, you would not have known that this is not correct unless you checked it. So I always ask my students to check it. It turns out that if you let's try two other numbers multiplied together to give you negative 48. Let's try 16 and 3. X plus 16, x minus 3. Let's check that. Let's check that. You multiply the outer two terms, you get a negative 3x. Multiply the inner two terms, you get a plus 16x. And notice how negative 3x plus 16 is a 13x. However, we wanted a negative 13x. So this is not right. This is not right. All right? So when you're off by a negative, we wanted negative 13, but we got positive 13. When you're off by a negative, all you have to do is reverse each sign. This was a positive. Let's make it a negative. This was a negative. Let's make it a positive. Let's check it one more time. The outers, you get 3x. The inners, you get a negative 16x. And notice how you get the negative 13x, just reversing the sign. So this is your final answer. Okay? So one of the things that you'll discover when you first start factoring, you might make a mistake, you try something different. You make another mistake, you try something different. Similar to what I did here. But the more comfortable you get with factoring, the more comfortable you get with factoring, you won't make any mistakes. You'll see right away the combination of numbers that yield a certain product that will, after checking it, will get that middle term to verify that you factored properly. With anything, the more you practice it, the better you get. All right, so let's move into a little bit more demanding type problem where you're asked to factor. Let's take a look. All right, so let's say we have something like, let's say we have 3x squared. Let's say we want to factor 3x squared plus 10x plus 3. We want to factor that. Now, hopefully you see there's a difference between this problem and the other problems that we've worked with. Here you got x squared, but here the difference would be 3x squared. All right, so let's go ahead and factor this. You can't pull anything out. So what you're going to do here is set up the binomials again. And then now you're going to ask yourself what two terms multiplied together will give you 3x squared. And you put the result here and here. All right, what two terms multiplied together will give you 3x squared? And the thing that you'd have to be able to see is you'd multiply 3x times x, and 3x times x will give you 3x squared. Then, after that, the terms that go here and here represent the product of the numbers that will give you a positive 3. Now, a mistake that a lot of students make is they try to do this in their head. They're afraid just to try something and possibly make a mistake. And if they can't see it in their head, they get intimidated. We don't want you to get intimidated. We want you to try. You know what two numbers multiplied together to give you 3, and there are not a lot of numbers multiplied together to give you 3. Let's try a positive 3 and a positive 1. 3 times 1 will give us 3. As I've said consistently in the show, let's check it. Let's multiply the outers, 3x, and the inners, 3x, and you get 6x. We wanted to get a 10x. This is not right. It's not right. And to be honest with you, I knew it wasn't right, but I'm intentionally trying to make a mistake, forcing students to go through the process of checking. Let's switch these terms. Let's put, instead of the 3 here and the 1 here, let's put the 3 here and the 1 here, and let's check that. Let's check that. You multiply the outers, you get 9x. You multiply the inners, you get 1x, and that will yield 10x, which is what we wanted to get, which confirms that this has been properly factored. All right, so x squared plus 10x plus 3, once factored, is the same thing as 3x plus 1 times x plus 3. All right, I want to reemphasize, when you're factoring at first, you're just getting used to it. It's okay. Till you try something, you mess up. You try something else, you mess up again. Don't get frustrated. You just keep trying the combination of numbers that will, you ask yourself, what two numbers multiplied together will give you that last term, and then you'll be fine. All right, let's look at another problem. Let's examine another problem. All right, let's examine another problem. Let's take a look at something like this. All right, so let's take a look at something like this. Let's say we have 2, or let's say we have 2a x to the second minus 2a x minus 12a. I don't know if you've been listening to what I've been saying very carefully, but for each problem, I've been saying, well, you can't pull anything out. You can't pull anything out here. You can't pull anything out here. And you can't pull anything out here. Because the reason I've been saying that is one of the first things you need to ask yourself is, can you pull out a common term? I'd like you to be able to see that each of these terms are divisible. You can divide a 2a out of each of these terms. You can divide a 2a out. And if you did that, you'd end up with 2a. 2a times x squared will give you this term. 2a times x will give you this term. And 2a times a negative 6 will give you this term. So that's the first step. In factoring, you always want to pull out what's called the greatest common factor. You always want to do that first. So I pulled out the 2a. And now what you want to do is go through the same process that we did in each of the first 3 problems. So you set up a binomial, a pair of binomials. You ask yourself, what two terms multiplied together give you x squared? Put an x here and here. What two terms multiplied together will give you a negative 6? A negative 6. You need a positive and a negative. And I'm not going to make a mistake this time because we want to get through one more problem. So you multiply a negative 3 times a positive 2 to get a negative 6. And if you multiply the outers and the inners, you get 2x minus 3x, and you'd get a negative 1x, which is what we wanted to get right there. You have properly factored this problem where your first step was to pull out the greatest common factor. All right, let's talk about one more. Let's try to get through one more example. All right, so let's look at something. Like 9. We only have a minute left. 9db squared minus d. All right, so here, again, you notice both terms have a d in it. you can pull the d out, and you're left with 9b squared minus 1, because 9d times 9b squared gives you 9db squared. D times a negative 1 will give you d. All right, so you pull that d down, you set up two binomials as we have before. Here there is no middle term, so two numbers multiplied together give you 3b squared are 3b and 3b. Two terms multiplied together to give you a negative 1 are a positive 1 and a negative 1. And if you multiply the outers and the inners, you get 3b, a negative 3b plus 3b, and you end up with 0, and there was no middle term, so this has correctly been factored. I've run over time.